Okay, let's get started. This is the second half of week 1. We're going to have that Excel assessment today, but before we do that, I want to get into some good stuff right away. So let's just go right to it right now. Here's our first subject right here. Frequency distribution, relative frequency distribution, percent frequency distribution. I'm just going to review real quick what a bar graph is and what a pie chart is, because I know all of you already know those two. I'm going to go kind of fast because we got that Excel assessment, but don't worry. Number one is, if I go too fast, you can always review the video. Number two is, this first assignment is so easy, that if you just attack it right after this class, you'll probably have it done in 15 minutes. It's going to be that easy. So don't freak out if I'm going too fast at all. This is how just today's going to be, because we have that Excel assessment we got to fit in. Frequency distribution, let's start there. Here we go. Take a look at these. Where's my pen? Right now I want you to look how many guests responded to the survey at this hotel. How many guests? 20 guests. There's 20 responses there. How many of them said poor? Help me out. 2. 2, thank you. How many said below average? Well, this is tough. I got to count them. 1. 3. Sure? Okay, as long as he's after 20, I'll be happy. Average. How many said average?
4.
4 or 5? 5. Is it 5? Okay. All right. How many said above average? Let's see, we're at 8, 9, 10, so there's 10 more up there. Above average? 9. That leaves, how many said excellent then? That leaves 11 maybe? That's impossible. Not 11. I'm way off. 9, 14, 15, 16, 17, 18, 19, oh, 1? There's only 1? Is that right? Everybody agree? Okay, here we go. You just created a frequency table. There it is. That easy. That's how you create a frequency table. You just count how many, you put them in order. I have them in the order from poor down to excellent. I counted them. You just made a frequency table. Now, you ready? Step 2. How many are there total again? 20. Get a couple calculators out for me, please. I need not only an answer to this, but I need someone to confirm someone else's answer. We got to take 2 and divide by 20. That one's almost too easy. 2 divided by 20 is 10%, isn't it? Yeah. So that would be 0.10. All right, I'll even put the 0 in front just to make it real obvious. But I need help with 3 divided by 20. 0. What?
0.5.
0.15. 15. Okay, got it. 5 divided by 20. That was pretty easy too. What is it?
2.5.
0.5. 2.5. Is that what I heard? Okay. 9 divided by 20. That's a big one. 0.4 or something. 4 what? 4, 5. What does that leave? This has to add up to 100. 45, 65, 75, 80, 90. What did he mean? 45, 55, 65, 70, 80, 90, 95. So without even looking, this has got to be 5%. 1 divided by 20, help me out. Is it 5%? 0.05?
Yeah.
It is. That adds up to 100%. We know we're right. Right here, 1.00. You just created a relative frequency table. We took how many observations there were of each piece of data, divided by the total number of pieces of data, and we left it in decimal form. Real quick, it looks like almost everybody's here. I want to mention, this semester, our goal is to take almost every number to at least 4 digits to the right of the decimal, and I know this is probably the first time for a lot of you to have to stretch a number out that far, but if you're rounding numbers, please, we're going to get in the habit of going 4 digits to the right of the decimal. I know it's a lot, but at least 4. And this makes a lot of sense. When we get into the later weeks, there's some calculations that start with so many zeros that you don't even get to a number until you get to the 4th digit. So that's why I need you to get in the habit of using 4 digits to the right. Next, the last type of frequency table that we have to create is called a percent frequency table. And all you got to do is take the relative frequencies, multiply them by 100, and put them under the title percent frequency, and you're making the assumption you're representing percentages. So here we go. 0.10 times 100 is 10%. 0.15 times 100 is 15%. All I'm moving is the decimal 2 places to the right for every one of these numbers. And when we add them up, if I did it right, they should add up to exactly 100% or 100. So 0.45 times 100 is 45. 0.05 times 100 is 5. If you add those up, they add to 100. Real quick up here, there's our data. Here is our frequencies, 2, 3, 5, 9, 1. Very good, thank you. You guys gave me the great calculations there. Here's our relative frequency, 0.10, 0.15, 0.25, 0.45, 0.05, perfect. And then here's our percent frequencies, 10, 15, 25, 45, 5, 100. That's it, that was pretty good. We almost had this whole first section done already. Real quick to refresh your memory as to what a bar graph looks like. Got the frequencies on the left, got the different subjects, poor, below average, average, above average on the bottom. Don't get me wrong, I don't see anything wrong with putting the ratings on the side, frequencies on the bottom, creating bars that go out this way. Still a bar graph. Either way, just let you see what a bar graph looks like. This is different from a histogram, and you have a histogram in your future, not this week. But I want to make sure you realize a lot of students will get bar graphs confused with histograms. They almost look exactly alike, but there is a significant difference between them. One of the main differences is you don't put any spaces between the bars on histograms. That's one of the differences. Now, pie chart. There's a pie chart. The circle always represents 100%, and then each sliver of the pie represents the representing percentage. So this first, here's the smallest one, 5%. You can see that's the smallest slice of the pie, and what I want you to notice in the pie chart is 10%, which is this one up here, is exactly twice the size of a slice of pie than the 5% is. That these are proportional to the percentages. So if there were a 20% up there, and there isn't, it'd be exactly twice the size of the 10% piece of pie. So that's how that's done. Everybody, you've all seen pie charts before in bar graphs, right? Just give me a shake of head here. All right, so that was it. Just wanted to refresh that. All right, now we're doing the Excel assessment. Everybody email, everybody check their sent folder, make sure it got sent to me and not sent to yourself. All right, that leaves us now with about 15 to 20 minutes to finish this material, which will then leave us with 10 to 15 minutes to do our in-class assignment. Don't forget your in-class assignment. You're supposed to compare it to at least how many other people? At least 2 from where? Different rows, different part of the room, right? You're comparing details. You're not just comparing, did you get this answer, did you get that answer? It's the details, the work. That's what you're comparing. Does that person have the same detailed work you have? That's where the points are at, not just the answers, the detailed work. So now, let's go here. Here's our instructions. This is our lifeline every week. If you ever say to yourself, what should I read to prepare for this first quiz? Go to your instructions, go to the materials down below. It tells you exactly which PowerPoint slides, which textbook pages, which Excel spreadsheets, and all of these materials that I post, you can have opened and ready to go while you're taking the quiz, including your book. Now, there's 3 parts of this week's assignment: the written, the number line, and the Excel. Let's look at, where do I want to start here? I want to start with the written. The written assignment says, manually show your detailed work finding the mean, median, and mode for the following data. How many pieces of data we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 13 pieces of data that you have to find the mean, median, and mode, showing your detailed work, how you found those 3 items. That's where the points are at. Some of it's kind of hard. How do you show this detail? Whatever's going on in your mind, write it down. That's the detail I need. Then there's this part of your homework, right here, which is saying there's some data here in column C. Let me see how far this goes. All the way down to cell 32, C32, C9. And it's asking you to to calculate the mean, median, and mode using Excel function equations. Don't forget though, this semester we're trying something different and we're handing everything in by paper. So that means yes, you're gonna put those 3 equations on there and you're gonna get 3 results, but you're writing down the 3 equations, starting with an equal sign, just like that. You're writing down the 3 equations, and then you're putting also next to those equations the results of each equation from the spreadsheet. And you're handing it in as a piece of paper with your written assignment, with your number line assignment, all on paper. And you just set it right next to the sign-in sheet or right here on the table. Matter of fact, today's class assignments, when you get done, just set them right on that table right here in front as you're heading out the door. And then the last part of today's assignment, or this week's assignment, is this number line, which is the last thing I'm going to be going over. But before I go over the number line, I want to talk about mean, median, mode, which is part of your written assignment. And then you got percentiles and quartiles, which means it could be on the quiz, because I'm kind of highlighting it, that mainly when I write the quizzes, and I write different quizzes every semester, I look at the previous semester to get an idea, but the questions will be different. Never seen on any other quiz before. I change them every semester. So, percentiles and quartiles, even though it's not your homework, could be on the quiz. So that's the kind of thing how you kind of say, okay, what's going to be on the quiz? Especially the areas I'm covering. Let's start with mean. Here it is. We're thinking about going to school at U of M Dearborn. Let's pretend this is last summer. And you want to move to this area, because maybe you're coming from a long drive away and your parents said, hey, or you can afford to live in a place. So you went ahead and called all these different 1-bedroom or efficiency apartments in town because you want to find what's the average price for an apartment if I were to live here. And you made 70 phone calls, which I applaud you for doing so. Or maybe you're just doing a research project and you had to find the average price. In statistics, the average is called the mean. So that's how you remember what the mean is. It's the same as the average. So if I want to find the average of these 70 sample rents, what do I got to do? If I want to find the average, what do I got to do? What's the first step?
Add them.
Add them up. It's exactly what you got to do. You got to add them up and then you divide by what in this case? 70, because there's 70 of them. So let me jump to the slide. There it is. You add them all up, came to 34,356 divided by 70 is $490.80. $490.80 is the mean or average mean rent cost in the area where this sample was taken, which we're pretending like it's Dearborn. So does everybody have a good idea now how to do the manual problem on your homework to find the mean? You got to write adding all the numbers equals, divided by however many numbers equals. You're showing your work. We got that. I know this is going fast because it's so easy. It's got to go fast just to make it at least semi-challenging. Median. The word I always used when I was in college, remember median, was middle. That was the word I used. Median means middle. But here's the catch on how to find the median. You got to know whether you have an odd or an even number, set of numbers, data, and you've got to put it in order, either from smallest to largest or largest to smallest, called ascending or descending. One of those 2 ways. You got to get them in order to find the median, and you got to put them in order to find the mode, which is the next item. So the median, this is hypothetical now. Here's if we had an odd number of pieces of data. There they are, 7 observations. Now we put them in order from smallest to largest. 12, 14, 18, 19, 26, 27, 27. Now we find the exact middle. Go from the outsides, 1 in, 2 in, 3 in. Look at that. Going exactly the same towards the middle from each end, we meet at exactly number 19. There's the center of the data. Real easy to find when you have an odd amount of data. Look at when we're at 19. 3 pieces of data to the right and 3 to the left. I mean, it's so easy to find median, but you got to show me on your homework that you took the data and you put it in order from smallest to largest or largest to smallest. And then maybe show something how you're trying to find the middle. And it's real easy when you have an odd amount of data, which, by the way, how many pieces of data is on your homework? Because I counted it when I brought it up. How many did I say? Anybody was listening to that? How many? That's right, very good, 13. So there's the example on how, when you have an odd amount of data, this is how you find it. This is the work I'm looking for. But if you have an even amount of data, look what happens. Now we have 8 pieces of data. We put it in order from smallest to largest. If we start going in from the outside, 1, 2, 3, 4, I'm on two different numbers. The center is that line between two numbers, because I have an even amount of data that have the exact center. It ends up being the little line between the 19 and the 26. So when that happens, you gotta add those two numbers in the center and divide by 2 to find the mean or average of the center. So in this case, the median is not 19, the median is not 26, it is 22.5. Those two numbers added together divided by 2. So everybody sees the difference now, finding the median when there's an odd amount of data or even amount of data, right? So here is 70 pieces of data. Let's go back up here. 70 is an even number. 8 is an even number. How many were to the left and how many to the right of that line that represented the exact center when we had 8 pieces of data? How many to the left? How many to the right? 4 and 4, because that's half of 8. 70 pieces of data. I want to find that line, because it's an even amount, where there'll be how many to the left? How many to the right? Perfect. Exactly half of 70. So let's count it off. Now I can see there's 10 in each row and 7 rows. So 10 is the first row, second row makes 20, third row makes 30, then go to the fourth row and count 5 to off. 1, 2, 3, 4, 5. There it is. 475 is the 35th number, and then 35 to the right would leave it at 475. The line between those two numbers is the exact center because we have an even amount of data there, 70 of them. It's just a coincidence that the two numbers on each side of that line are the same number. So it makes it very easy. Add 475 plus 475 divided by 2 is 475. So it makes it very easy to find the median in this case. But don't, but you see the concept, right? Because they won't always be the same number. Matter of fact, pretty odd. So you see the concept though, where we have the same amount to the left, same amount to the right. You now can find the median for even a number data. Next, mode. The word I always used to remember mode was most. Whatever data appears the most is the mode. Let me repeat that. Whatever data appears the most is the mode. Here's the bad news. Sometimes there's more than one piece of data that shows up the most and ties. If there's two different pieces of data that both show up the most, that's called, let me jump down here, bimodal. If there's more than two pieces of data that show up the most, it's called multimodal. And so if you have a question on the quiz, it may be, for example, does this data have a mode, a bimodal, or a multimodal? And so you've got to know the definition to tell me the answer to that. You're looking at the data to see if there's a tie or not on whoever has the most. Let's go to the right. To find the mode, you've got to put it in order from smallest to largest or largest to smallest. And then what I always do is I start at the top corner and I start counting. I say, okay, where's there some data that repeats? I start at 425, I go to 430. There we go, 430 repeated. There's 2 of them. So right now, 430 is the mode, but I'm barely got into the data, so let's keep going. 435, well look at that, it's also repeated. 1, 2, 3, 4, 5 of them. So 430 is no longer my mode. 435 is the mode right now with 5. So I'm looking to see if there's any more data, more than 5 of them appearing. Let's see, 440, 1, 2, 3, 4, 5. Uh-oh, I got bimodal now. I got 5 440s and 5 435. I got a tie going on. I'm gonna keep going though, and you keep going, and we get to 450, and look what happens. 1, 2, 3, 4, 5, 6, 7. 435 is not part of the mode anymore. 440 is not part of the mode anymore. 450 has 7 of them, and then I keep going, and I find that no other number has 7 or more. So our mode is only a single mode, and it happens to be 450. But if you're showing me work on that written part of the homework to find the mode, you got to show me that you put the data or from smallest to largest or largest to smallest. And then you got to start saying, oh, maybe write something like, oh, there's 2 numbers that are showing multiple times, but this number's the most, so it's the mode, or something like that. Just show me what's going on in your mind to determine what the mode is from the data on your homework. Write something out to show work, to show detail as to how you came up with your answer. Does everybody feel comfortable they can find the mode of some data, especially when you only have 13 pieces of data? Can you find the mode?
Yes.
Can you find the median?
Yes.
Can you calculate the mean?
Yes.
All right, you're ready for that homework. That part of the homework's done. Now, there's a couple other parts that are not on your homework called percentiles and quartiles. Look at that, we got about 5 minutes to get through percentiles, quartiles, and the number line, so we have time for the in-class. Now, I'm rushing, and I know someone always freaks out when I rush on this first lecture because of this Excel assessment. I'm gonna have to rush a little. But as you can see, this first homework assignment is so easy that don't sweat it. You can watch the video again if you decide to put off doing this homework right away. This is gonna be so easy. So let me keep going. This is not part of your homework, but I wanna make sure and cover this. Here's the trick to percentiles. The trick to percentiles is this little calculation. You gotta say, is the result an integer or not an integer? That's the key to this. So, let me jump to the first example. You see 70 pieces of data there, right? And they're in order from smallest to largest again, because when you're doing percentiles and quartiles, you've gotta have them in order, either from largest to smallest or smallest to largest. Actually, it's almost always smallest to largest when we're doing percentiles and quartiles. Now, if I said to you, what is the 80th percentile of this 70 pieces of data, you would go, okay, 0.80, which is 80%, times 70 pieces of data gives you the location of the 80th percentile. But, here's the key. 0.8, right, 80 over 100 is 0.8 times 70 equals 56. You would say, oh, 56, the 56th position is the 80th percentile. But no, because it calculated the 56 and not 56.1 or 56.9 or 56.5, just 56, you have to go to the 56th and the 57th. You gotta go up one and find those two numbers, add them together, divide by 2, that's your 80th percentile. This only has to happen when that calculation turns out to be an integer. It doesn't have a point anything, like 56 or 46 or 45. If that were 56.1, we'd be going to the 57th position, and we don't have to do any calculating. Just find the number in the 57th position. If that were 56.5, we're going to the 57th position. You always round up when you're doing percentiles and quartiles. Let me say that again. You always round up unless it calculates out to an exact integer. Go ahead and answer your question.
You answered it when you,
Okay.
I was gonna ask you
All
about
right,
the
we
point.
could go to the next one, yeah. All right, so now, let me show you 75th percentile. Watch what happens. Let me get to it right there. 0.75 times 70 is 52.5. That's not an integer. That's got 0.5 with it. So we don't have to find two different number or two different positions and add them, divide by 2. We go straight to the 53rd number. So 10, 20, 30, 40, 50, 51, 52, 53. 525 is the 75th percentile. All right, get calculators out. Let's do one more. I want to make sure you get it. I know we're out of time, but I want to make sure you get this. Give me a percentage between 1 and 100 that we haven't covered. Not 80%, not 75. Give me another one.
63.
I heard 65 back here, I think. And then I heard 63. But let's try 65. 0.65. What do I multiply times when I have 70 pieces of data?
7.
70. Very good. Give me the answer. What is this exactly? Give me at least one digit to the right. 0.65, 0.7 is equals what? 45.5. Is that correct?
Yes.
45.5. What position would I use to report now the 75th percentile of this data? What position?
46.
Exactly. You've got to go to the next one because that didn't calculate out to exactly 45. If this would have calculated out to exactly 45, you go to the 45th and the 46th, add them together, divide by 2. You got that extra step only when that calculates out to exactly an integer without point anything. But as long as you got 0.1 or 0.2 or any point something, you got to go up to the next position and find that number instead. So let me go back to the 80th percentile. I want you to see this. There's the 80th percentile, 56. But because it turned out to be 56 on the nose, we had to find the 56th number, which is 535, and the 57th number, which is 549. we added them together, divided by 2. The 80th percentile is the average or mean of those two numbers, which is 542. Everybody see the difference? Okay, we got percentiles. Now, quartiles. Quartiles are percentiles. But if somebody's asking you for the first quartile, it's the 25th percentile. It'd be 0.25 times 70. That's the position, and then you find that number. If they're asking you for the center quartile, it's the 50th position, which is also the median. The median is the second quartile. And if it's asking for the third quartile, that's the 75th. I thought we did 75th. The 75th percentile, which is on this slide right there. There's the 75th percentile, which is the third quartile. How do we feel? We understand which each quartile is. We can calculate a percentile. All right, let's go to number line. We want to make sure I have enough time. Here we go. This is your number line assignment. Look at, I got 2 lines up here, but look at what I did. You must do this to both of the number lines that you have for your homework. You draw a line, you put the arrows on the end, right in the middle, put the word mean. See, I did it twice. You can put a +1 or just a regular 1. Sometimes I'll add a plus. +1, +2, +3, -1, -2, -3. 1, 2, 3, -1, -2, -3. For this class all semester, we're doing this a bunch of times, and we have to be able to analyze this number line a bunch of times. This is the beginning of a bell curve. This is the beginning of a bell curve. We're focused on just the number line right now. And what I want you to do is I want you to show me that you can easily determine what numbers would go underneath each one of these if you're given the mean and what's called the standard deviation. Here's how you do it. If I said the mean is 100 and the standard deviation is 6, you've got 100 right there underneath the mean. You're going to show me work to find that first standard deviation above 100. You're going to go, well, 100 plus 6 equals 106. So this one, I didn't leave enough room, 106. Now I take this, I'm going to add 6 to it, and this equals 112. Now I'm going to take this and add 6 to it, 118. The 100's in the center, 106 is at the +1, 112 is at the +2, 118 is at the +3, because I added 1 standard deviation to the 100, then I added 2 standard deviations to the 100, then I added 3 standard deviations to the 100. Everybody see where those numbers came from? Let's go in the other direction. I'm going to subtract 1 standard deviation. I'm going to subtract 2 standard deviations. I'm going to subtract 3 standard deviations. I'm going to try to do it in my head. 100 minus 6 is 94. There's that one. 94 minus 6 is 88. Correct me if I'm wrong. I think it's 88. Looks right. 88 minus 6 equals 82. Look at, now I got my numbers to the left. 100 is the mean, 94 is at -1, 88 is at -2, 82 is at 3 standard deviations below the mean. That's what these numbers represent. It's how many standard deviations above and below the mean. 1, 2, and 3 each direction. So on your homework, I want to do one more. I need something with a point though. Something with, let's use this number right here. Let's pretend this is our mean. 45.5. And our standard deviation, I'm making one up, 2.2. Now these are not integers. I got point something. But your assignment is to draw a number line, put these numbers in the middle, your mean, your standard deviation, 45.5, 2.2. Show your work to determine what the numbers are on the number line for each one above and below. I'm going to do my work up above here. 45.5 plus 2.2 equals 47. So this one's 47.7. Your number belongs right underneath where this dash is. Because above, we're eventually putting in here what's called a bell curve, but not yet. We're not there yet. We're just doing the numbers right now. Focus on just these numbers. You have 2 of them to do on your homework. I'm going to go the other way. 45.5 minus 2.2. 5 minus 2 is 3. 5, 3, 43.3. 43.3. Does everybody get what's going on here? I would then add another 2.2, add another 2.2 to get those numbers, subtract 2.2, subtract another 2.2 to get those numbers. Do you feel like you can do the number line part of your assignment?
Yes.
Everybody gets it? Let me just show it to you real quick. so you can see it. Again, I go over that example in the first half to show you the instructions. There's our numbers. 106, 112, 118, just like the example there. What does it say? 94, 88, and 82, just like the example. And then down below here are your assignment. So your first one is saying the mean of the data is 118 liters, the standard deviation is 12. It's asking you to come up with the 6 numbers. You can write them on here or write them right on your number line if you want. You don't have to write them on there. You can write them on your number line. It's up to you. You write them on that or write them on your number line. You can draw your number line on this too if you want. As long as you're handing in all 3 assignments on Thursday when you first get in here, before 11 a.m. Go ahead.
Do you have to print off these papers?
It's up to you. So you don't have to know. I'll take just the numbers and a number line with the numbers below the ones and below. As long as you're showing me your calculations. You can do it however you want. But I gotta see the work, so I'll come back in a minute.
Would you like us to do it on 3 separate pieces of paper?
No, you can do it all on one piece of paper if you want. I cram it all in there, just as long as I can figure out where your answers are. You know, and save paper, why not? Save a tree.
I was gonna ask you.
Okay, all right. All right, and then you have a second one. Now the second one's a little harder. 28.3 pounds is the mean, and the standard deviation is 1.2. I mean, only because there's points there, it makes it a little harder. That's your whole homework assignment. Oh, except for one more thing. I almost forgot. You have to be able to calculate the mean, median, mode using Excel. Are you ready? Whoop, hang on, where's the first? There we go. Okay, here we go. There's the first one, equals average, A-V-E-R-A-G-E, parentheses, B8, so right there, B8, let me get back here, dot, dot, see the colon, B25. Look at it, even includes letters. Whoops, hang on, I gotta scroll down. I wanna make sure we got enough time for our in-class here. It even includes letters. So what it did, this command, average, adds up all the numbers, ignores the letters, and divides by however many cells had numbers in it to find that average. Whoops, what's going on? That number sure, yeah, 67.875. All right, median, M-E-D-I-A-N, parentheses, where's the data located? B8 dot dot B25. Listen, when you write these answers out on paper, you've got to include that equal sign in front. See that equal sign? Exactly how you type it into a cell is how you write it out, and then you would give the result, 60 in this case. And then mode, M-O-D-E, equals M-O-D-E, parentheses, wherever the data's at. And you're gonna write that out and then you give your answer. But the data is, on your homework, is instead over here from C9 to C32. Does everybody feel like they can look at that example and be able to write the Excel equations for mean, median, mode for this assignment?
Yeah.
You want to email to me right now?
No, this spreadsheet's not emailed to me. You're using it just to find the results. You're handwriting those 3 equations out and the results. You're using this spreadsheet as your guide, just like you were doing that assessment. You're using the spreadsheet, but don't send me the spreadsheet. I don't want it.
So when we write down the equation, are you looking for just the equation?
And then the result next to it.
Well, like if I write like
Let's say you're.
9, would
Yeah.
you like understand that? Or
Hang on.
do I have to write
If this were your homework, you would write equals A-V-E-R-A-G-E, parentheses, B8 dot dot, and then you would write 67.875 next to that.
Yeah.
That's it. Is that, I don't know.
Yeah. Yeah.
You don't move your data. Everybody's gonna have the same answer as long as you don't move the data the way that is on the spreadsheet. Because if you move it, he's right. If he moves it, I think you're asking, am I gonna know where your data's at based on the letters and the numbers you put in there, right? Yeah, but don't move your data. I'll know where it is because you're gonna use, everybody's gonna have the same answer because we're all gonna use the same spreadsheet. All right, you guys, you ready for the in-class? Does everybody feel like they can do the homework? Does everybody feel like you can get the homework done in like maybe 30 minutes or less? Okay, good. If you wait till Thursday morning to do this or Wednesday night, the best bet is to go back to the video. I'm gonna edit out the whole Excel assessment part of the video, so it's gonna be a lot shorter than an hour. And you can jump and get to the part where I went over the part you're trying to remember, okay? All right, let's do it. Here's the in-class assignment. Everybody hands in their own. Take a piece of paper out, put your name on it. You hand in your own answer, but you're comparing with at least, you can go to more than 2, but at least 2 other people from different parts of the classroom than right next to you. Don't, you know, you can compare right next to you, but please get up and go and check with someone else. Here's today's assignment. Can you see it okay?